Hello there and welcome. In this lesson, we're going to learn about interfaces. Usually beginners have issues understanding interfaces, and that's just because they don't really understand what is the purpose of interfaces and how to actually use them, not because interfaces are hard to understand. An interface is like a contract that defines what methods or properties a class must use. So interfaces do not contain any kind of implementation, they only define what must be done, not how it should be done. So if a class decides to implement this interface, it must implement all of these methods or properties that are enforced by the interface. And why do we need this? Sometimes we want to separate between what a class should do and how it should do it. Now we can create these interfaces in a separate file, and this is the best way, but for the example, I'm going to create them inside this program class. So to create an interface, we're going to provide a public access modifier, and then I'm going to say interface and the name of the interface. There is a convention to start a name of an interface with an I, because I stands for interface, and it will be much easier to recognize it as an interface, but you don't have to do this. Let's say we have an interface named I vehicle. Then we're going to create these curly braces, and inside we need to add methods that are going to be enforced by this interface. So what is the functionality that a vehicle must have? Maybe it will have a void start engine, right? Because all of our vehicles have an engine. Now this may not be correct because a bicycle is also a vehicle, I think, and it doesn't have an engine. So maybe we should say something like start moving. Then we may also have a method to start or stop moving. Another thing that we can include is maybe increase speed. And also decrease speed. So we can think about others as well, but you can see what is different. We are not implementing these methods. We don't have these curly braces here that will contain the code. Inside of an interface, we are only providing the method that should be implemented inside of the class. And it means that if a class is going to implement this interface, it must have all of these methods. Now, it doesn't only have to be methods, it can also be properties, for example, public int speed. So interfaces cannot have fields, but they can have properties. So each vehicle will have a speed, right? And it will also have all of this functionality. And we can basically make sure that each kind of vehicle will certainly have all of this. Now, if we create a public class car, and then also a public class train, then obviously we can add all of these inside of the classes and be done with it. But we want to make sure that these are obligated to use these methods and these properties. So to implement this interface, we can use this colon here and then implement the interface. Now it's going to give us an error because we are implementing this interface, but we don't have all of this. So it will also tell us car does not implement interface member, increase speed, or start moving, or speed. So we can either add them manually, public void start moving, and this time we need to actually provide the implementation. We need to provide the code of how to start moving. but it will still give us an error because we still need to implement all of them. And only when we implement all of them, this error will be gone. Now, an easier way is to just right click or hover, quick fix, implement interface, and it's going to implement all of them, or it's going to add them automatically. Now it will still tell us that this is not implemented because there's still no code inside. But now we don't see this error anymore because we have all of these methods and we made sure that this car has all of this functionality. It can start moving, it can stop moving, it can increase speed, it can decrease speed, it has this speed property. And that's the point with interfaces. Now, if we want our train to also use all of these, or basically make sure that it uses all of these, then we can implement this iVehicle interface. And again, we can just go here, implement interface, and it's going to implement, or not implement, but add all of them because they're still not implemented, but they are contained in this train. Now let's say tomorrow your boss or your manager is going to tell you that you need to develop another vehicle. Maybe it's a game or something like that. Maybe you need another vehicle in your game. So you have a car, you have a train, and maybe your manager tells you that you need to develop a public class motorcycle. Now your manager is not going to tell you exactly how to create this class. What your manager cares about is the functionality that this vehicle will have. He cares about having all of this. So your manager is not going to tell you, okay, create a motorcycle vehicle and do this and that. He will tell you, create a new vehicle that will be the motorcycle vehicle and just make sure that it uses the iVehicle interface. Because your manager can be sure that if you are using this interface, then you basically covered everything a vehicle should have inside. So your manager is going to tell you, make sure it implements iVehicle. That's it. That's what your manager is going to tell you. So you're going to create this class, motorcycle, and you're going to implement iVehicle. But now, because you implemented this, you also need to make sure that all of these methods are included in this class. And now it's going to be your job to add the logic inside. It's going to be your job to figure out how this motorcycle is going to start moving. Because the logic inside of this motorcycle will be different than the logic inside the train, right? To start moving a train, you should start the engine, maybe there is some kind of sequence, maybe something. You have a very specific train logic. But inside of the motorcycle, you will have specific motorcycle logic. So your job is going to be to implement and add logic to these methods. Now you can't just come tomorrow and say, well, this annoys me, I don't want to create this method, it's a hard method, I don't want to think about the logic. I'm just going to remove it from this class, okay? I'm just going to tell my manager I finished working on the motorcycle class, but I don't want to have this stop moving method. This is not going to work because you're going to have this error. Because by implementing this iVehicle interface, you must have all of these methods. So it's like a contract. You must follow these rules. You must have the start or stop public void stop moving method. You must have it because a vehicle should know how to stop moving. Imagine without this, your motorcycle wouldn't have a way to stop moving. It wouldn't have any brakes. Imagine you create a real motorcycle. Maybe it's not a game. Maybe it's a real motorcycle prototype. And you created this program and they installed this program on the motorcycle. And now the motorcycle doesn't know how to stop. People will die and you're probably going to get fired or even go to jail. So by implementing this interface, we are making sure all of these important methods are included. So this is exactly the point of interfaces. It's a way to make sure some code is included inside of the class. We don't care how it's implemented. We care that it actually is getting implemented in our classes. Now, it doesn't end here. We can actually use this in our logic. For example, if I want to have a reference to one of these methods without specifying the type of class, I can have a reference of iVehicle, and inside I can store a reference to a car. Now this may look very weird to you because we learned that if we create a car object, we need to store it inside of a car object. But if we create an interface variable of type iVehicle, we can still store this car object inside. But what will happen is that we're not actually storing this car object inside, we are storing a reference to the interface. And it means that we can access these methods. Now I can do the same with other vehicles. And you can see that both car and train can be stored inside this iVehicle because they are vehicles. And we can use these methods because we know that a vehicle will have this method. So it makes the code much more flexible. It uses abstraction, and we're going to learn about abstraction in a different lesson, but that's the point. We don't care about the specific class or object. We care about the functionality. We care that we can move it, and we don't care how it's being done. It means that we can also create a list of vehicles, of iVehicles, and then inside we can add vehicle 1. We can also call it car, and this one will be train. We can add the car inside, and we can also add the train inside. Now we don't have to do this. We can actually have this car object added inside. And again, we are not storing the actual object. We're just storing a reference to the interface. We can also add a motorcycle, right? Because a motorcycle is implementing this. Now again, we forgot this start or stop moving method. So again, we can add this method, or we can go here, implement interface, and it's going to add this automatically. So now we can also add this motorcycle because it's also implementing this iVehicle interface. And now we have a list of references for vehicles, and we don't care about the type of vehicle. We can then go and do something like for each iVehicle in vehicles, start moving. So this part of code is abstract. We don't care about the specific type of object. We only care that it's a vehicle and that it can move. So it's a bit hard at this level to understand when will this be useful in your code, but it's actually useful in different situations. Now, if we go into these specific classes, we can add specific logic. For example, we want to print car started moving. But here inside the train, we're going to say train started moving. And inside the motorcycle, we're going to say motorcycle started moving. So each one will have its own logic, but they're all vehicles. And when we run this code, we can see that each type of object used its own logic. Car started moving, train started moving, motorcycle started moving. So we did not specify the specific type of vehicle, we just said that all the vehicles should have this. So if we need to run some kind of method without specifying the object that is using this method, we can basically reference the interface or create an interface to do this. We just want to make sure that all of these can move, or maybe all of them can increase their speed, or maybe all of them can do something in common. And this way we can reference this specific functionality without referencing all of them. Also, you should know that a car can have specific logic for a car. Maybe public void check air pressure. Right? Maybe you want to check the air pressure inside of the wheel. Maybe we also have a wheel size. But our train doesn't have this, right? Trains are moving on rails. They don't have wheels. So it doesn't make sense to have this method check air pressure inside of the train as well. So only a car will have this method, but a train won't have this method. And it doesn't make sense to add this into this interface. Otherwise, the train will have to implement this method, but the train shouldn't implement this method because it doesn't make any sense. So this is a specific method for a specific type of vehicle. That's why it should not be a part of this interface. We only want to make methods and properties a part of an interface if all the members of this interface, all the classes that are implementing this interface should have them. Now, maybe this car should have check air pressure, but maybe our motorcycle should also have this, right? Because a motorcycle also has wheels. So you can add this specifically for motorcycles and cars. But what if you want to be a bit smarter? You can actually create another interface only for vehicles that have wheels. Public interface I has wheels. So maybe it's an interface for all the classes that have wheels. So maybe I wheel. And this will be used only by vehicles that have wheels. But now we are not going to implement this instead of the vehicle. We are going to implement this as well. So we can implement many interfaces with the same class. Let's take this method and make sure it's a part of wheels, of iWheel. Let's also take this wheel size and make sure it's implemented. So now my car is implementing both iVehicle and iWheel. And now it will enforce and make sure I'm using this. And also my motorcycle is going to implement I wheel. And then it's going to make sure that I have implemented this check air pressure and wheel size. So now you start to understand why interfaces are important. It makes the code much more efficient. Obviously, we can have even more of these. And by having this I wheel, we can then do other things. Maybe we have some kind of gas station in our game. So maybe instead of this, or also let's create another interface. I fuel, or maybe some better name, I fuelable, or something like that, just to make sure that this vehicle uses fuel. So then we can have this method, public property, public int fuel capacity, and maybe also fuel amount, and also a method refuel. And maybe we also want to provide a parameter here, amount, how much fuel we're going to refuel. So we can also provide parameters as part of the interface. So each type of vehicle that is going to have fueling should implement this interface. Now again, a car should use this. And we need to make sure that it will implement this. A train, on the other hand, doesn't have fuel. Some trains may have, but usually it's either electric or maybe it uses coal. So it doesn't make sense to have this iFuel interface on our train, but it does make sense to add it on the motorcycle. And now we're going to implement all of this, and we need to add. Obviously, later we're also going to set these values when we create the actual object, right? When we create a motorcycle, it will have its speed, it will have its fuel capacity, because this is just the class, it's the blueprint. But now it will have this refuel method, and it will have all of these because it's going to implement these. And now, because we are sure that these vehicles can refuel, maybe in our game we have a gas station, and when the vehicle approaches the gas station, instead of checking, let's say we have this car, new car, instead of checking if car fuel amount is smaller than 0 or something like that, or smaller equals 0, then use car refuel and also provide the actual fuel or something like that, maybe 10 gallons. This is not efficient code because we also have motorcycles. We want to be generic, so then we also need to say or motorcycle fuel amount is smaller than 0, then also, but then what? We don't want to refuel both car and motorcycle, so maybe we can do an if else, but that's also not efficient. You can see that it's going to start to be complicated, especially if we have 100 different vehicle types. We don't want to do all of this. Instead, what we can do is say I fuel refuel. Okay, so let's say it's a car, but we don't really care right now if it's a car or a motorcycle. Imagine we're going to have this method or this class on a different object in a different script, so we don't really need to provide it at the moment. But we're simply going to set the reference later, right? So this will be set later, this new car, or maybe it's not even a new car. Maybe we're going to have a car, player, car, new car. And then later, when the player gets into this gas station, the reference is going to be set. And then it will set the reference and use this interface. So now we're going to check, or maybe let's refuelable, okay? And then we don't need to do all of this. We only do this. We don't even need to check if the amount is under, well, we can do this, but we don't need to check if it's some kind of class that can be refueled, because if it's a refuelable, we know that it can be refueled. And then we can say refuelable, refuel. So that's all for this lesson. I hope it was not too complex. You can watch the episode again, maybe things will click. Please subscribe, you can also leave a like, you can share, you can comment, and I'll see you next time.